Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we'll try to finish section 1B of the AP Calculus BC course. We have 8 problems remaining. So the first one is an integration problem, number 38. It says integrate dx over x squared plus 6x plus 10. And they give you some inverse trig functions. So you should know. I mean, this is just by looking, you would know the answer. But what you see in the denominator is something that, it's a quadratic equation. So you want to complete the square. And you would say, well, okay, so this is the integral of dx over x squared plus 6x. Now, if you divide 6 by 2, you get 3. You square it, you get 9. So you want 9, but you have 10. So you have to say plus 1. You see that the first one is x plus 3 square plus 1. And that reminds you of the inverse tan. You have dx over x squared plus 1. But instead of x here, you have x plus or minus anything, which doesn't affect anything because the x is not doesn't have a coefficient multiplied by it. So you should get arctan x plus 3 plus a constant, and that's an easy one, and it shouldn't take you any time. In fact, just by inspection, many of you will get it. That helps you in other problems that may take longer time. Number 39. Number 39, they tell you if the path of the particle is given by x of t equals 2t squared minus 3t plus 1, how far does the particle go between t greater than or equal to 0, less than or equal to 4? Okay, so when you have a problem like that, if that was a linear, the problem would be trivial, right? You say x of 4 minus x of 0, and many would say x of 4 minus x of 0, which will not be correct in this problem because you see, once you this is a quadratic equation, right? It's a parabola. And you can see that the axis of symmetry is between 0 and 4, right? It's 3/4. Right, negative b, which is 3, over twice a, which is 4. So why isn't it correct to do x4 minus x0? So this is the t, and this is the x. And here is the axis of symmetry at x equals 3/4. At t equals 0, you get x equals 1, so you are here. 0 and 1. You see, from here to here, you are going down because that's a parabola opening up. So you're going to move in this direction, then in that direction. So if you do x4 minus x1, it will give you this. You can't. It will tell you this minus that, which is not correct. But definitely it would be one of these answers. Without doing it, I know. So in this case, you have to find what is x of 0, what is x of 3/4, and then what is x of 4. X of 0, we know it's 1. What about x of 3/4? 3/4 square is 9/16 times 2 is 9/8. 3 times 3/4 is 9/4. This is twice as that, so when you subtract it, you will get negative 9/8 plus 1 equals negative 1/8. And we still have x of 4. 4 square is 16 times 2, 32. 3 times 4 is 12, plus 1 is 21. So those of you who would have done x4 minus x1, you get 21 minus 1 is 20. Sure enough, they put it dangling in front of you here. And those who will do only x of 4, they say x of 0 has to be 0 without looking at the equation. So 21 minus 0 is 21. So that's another answer. So let's see what we get. How do we calculate the total distance? This thing is going from 1 to negative 1/8. Then at 4, it's going up. Oh, I'm sorry, 1 and negative 1/8, 3/4 even, not 1. And then 4 and 21. So really you have to use an absolute value. What is x here minus x there? So you say distance equals the absolute value of negative 1/8 minus 1 plus the absolute value of 21 minus negative 1/8. Okay, so this is negative 9/8. So when you take the absolute value, it becomes 9/8. And this is negative times negative is positive. 21 plus 1/8 is 21 times 8, 168 plus 1. So 169 over 8. You add them up, you get 178 over 8. There is nothing here over 8. It's not the same. But you see, excuse me, these two numbers are even. So you divide by 2, you get 8, and 18 over 2 is 9 over 4. 89 over 4 is E. So the answer is E. Again, it shouldn't take that long, but again, I'm trying to write everything in detail. If the axis of symmetry was on the left of 0 to 4 or on the right of 4, so left of 0 or right of 4, x4 minus x0 would have been correct because either the particle is moving in one direction, up or down. But because they place this in the middle, you have to break it into two parts and calculate the distance in each part separately and then add them up. Alrighty, number 40. Number 40, by the way, I was taping this earlier. And I was using the left-hand Riemann sum as they did. And my answers turned out to be 97, which is not here at all. I said, maybe I did a mistake, and I repeated it. And then the video was getting longer, and it's like I had to cancel it and repeat all again at this point. I should have solved them earlier, but I said, we can do it together. Hey, okay, so if you do right-hand side, meaning, do you see these are the x's and these are the f of x's? So between 13 and 15, the height would be 13 because we are doing a right Riemann sum. Okay, so you would say the area equals the height, which is 13 from the right. So I'm not going to use the 2 at all. The last will not be used. Okay, so it's going to be 13 times 2 plus 12 times 13 minus 10, which is 3, plus 9 times 10 minus 8, which is 2, plus 8 times 8 minus 7, which is 1, plus 4 times 7 minus 3, which is another 4, plus 3 times 3 minus 1, which is 2, and finally plus 6 times 1 minus 0, which is 1. So that will give me 36 plus 26, that's 62, plus 18, that's 80, plus 8 is 88, plus 16 is 104, plus 6 is 110, plus 6 is 116. Again, you have a calculator in this period. 116 is C. As you can see, it's left, it's right, not left. Let's keep the calculator here if we need it. I think we will have to need it. Okay. Move to number 41. Okay, so number 41. Find the length of the curve given by y equals 1/3 x squared minus 2 to the 3/2 from x equals greater than or equal to 0, less than or equal to 4. Okay, we know the equation for the curve, right? And basically it's coming from the idea is that when you pick 2 points along, I'm doing it here so we have the space. You say this is dx and this is dy. So this part is really the square root of dx squared plus dy squared. Then I'm gonna multiply and divide by dx squared. So inside I will have dx squared plus dy squared. I'm going to divide by dx, but under the radical it becomes dx squared, and multiply outside by dx. This over that would be 1. This over that would be y prime square dx. And then I integrate. So I'm going to find y prime first. Y prime is 1/3, and then I'm going to take times 3/2 times x squared minus 2 to the 1/2 times 2x, which is the quantity inside the derivative of x squared. So the 2 and the 2 cancel, the 3 and the 3 cancel, and I get this equation, right? So length equals the integral from 0 to 4 of the square root of 1 plus the square of that. What is the square of that? The square of x is x squared. The square of this thing, which is a radical, the square would cancel the radical, and you get x squared minus 2 dx. So it's the integral from 0 to 4 of the square root of x to the 4th minus 2x squared plus 1 dx. You should see the quantity under the radical as being a perfect square. It's x squared minus 1 quantity square. So that becomes the integral from 0 to 4 of x squared minus 1 square under the radical. The radical and the square cancel, and you get x squared minus 1 dx. See how it's simplified nicely? Now when you integrate, you will get x cubed over 3 minus x evaluated from 0 to 4. When you evaluate at 0, you get 0, so you don't care about that. You will get 64 over 3 minus 4. Is that one of the answers? Yeah, it's C. So you don't even need to take a common denominator or anything. It's C. So luckily, that was an easy one. Okay, we move to the next one. And the next one says find d dx of the integral from 1 to x of t minus t to the 4th dt. Yeah, this is the second theorem of calculus. Since this is a constant, you just ignore it because the derivative of a constant is 0. And that if that's an x, it's not a function of x. All what you have to do is to say, well, it's x minus x to the 4. That's it. It takes 5 seconds. Okay. And that's E. X minus x to the 4th is E. The next one needs some space. Probably I'll get a new page sheet. And we look at number 43. We have 3 more. A cylindrical pool. So I have a cylindrical pool. That is being filled at a rate of 96 pi cubic feet per hour. If the radius of the pool is 4 feet, how fast is the height changing? Meaning, what is dH over dt? Oh, yeah, okay. So again, related rates. I have a rate. Notice the feet cube is a cubic feet is a volume and hour is a time. So basically, that's dv dt. So I have to write the volume, and the volume is pi r square h, right? So dv dt equals, the radius is constant. Remember in the previous problem when we had a cone and we said we have to relate the radius to the height because I cannot have two variables and take the derivative with respect to one unless I know what is dr dh, for example. It's easier to transform everything in h. Here, r is a constant and it's 4, so 4 squared is 16. 16 pi will never change whether the water is at this height or at that height. And that's why they didn't tell you what is the rate at which the height increase when the height is, for example, 5 feet. It doesn't matter. It's a constant rate because the cross-sectional area is the same. It doesn't matter, right? So this is 16 pi. There is no r. They didn't have to switch the r into h because there is no relationship between them. But then they tell you this quantity is 96 pi. Wow, could it be any easier, right? I'm going to divide by pi and then divide by 16. That would make it 6. So it's 6 feet per hour. And that's D. This is the easiest problem, probably. And then the last two. Let's look at 44. 44 says a child jumps on a trampoline and rises at a rate of 10 feet per minute. The child mother is watching from the patio 40 feet away. So here is the trampoline. Let's say this is, and the woman is 40 feet away. And the patio, we assume it's at the same level of the trampoline. You have to make some assumptions here, I think. How fast in radian per second is the angle of elevation between the trampoline and the mother's line of sight of her child increasing when the child is 30 feet in the air? So the child jumps here until he's 30 feet in the air. Wow. And then he's going up at a rate of 10 feet per minute. If we call this angle theta, we want to know d theta dt. So this is basically h, right? Because he's keeping, it's like when we do the cone, we use r and h, but then they tell you what is the value when the level of water is, say, at 7 feet. So now you replace. So I cannot use the 30 or else I will have this line that doesn't change. No, the h, this height is h at a specific time. But generally speaking, I have a triangle that has a base of 40 and a height of h. Okay? So um, so no matter what the height is, we can say that uh, h over 40. So we can say tangent h. That's easy because the hypotenuse is changing, but this is 40 and this is h. So it's easier to say tan theta, I think, is h over 4. And why do I need that? Because I need to find d theta dt. And then I would substitute when her son or child is at 30 feet high. So when you take the derivative of both sides, you will get derivative of tan is secant square theta d theta dt equals 1 over 40 dh dt. dh dt is the rate of change of the height, and they tell you he is rising at a rate of 10 feet per minute. Oh, but then they ask you radian per second. They tell you radian per second. So we have to translate that into 10 divided by 60, so 1/6 feet per second. Okay, so now 1 over 40 times 1 over 6. But what is secant square? At the time the guy is here, this is 3, 4, 5 triangle, right? 50, 30, 40. And this is theta. And secant is 1 over cosine, meaning 40. Cosine is 40 over 50, so this is 50 over 40, or 5/4 squared. So 25/16 d theta dt equals 1 over 240. That's basically it. If you use your calculator, you will see that 16 times 15 is 240. So d theta dt is 1 over 25 times 15, which is 250 plus 125, 375, right? Yeah, 1 over 375 radian per second, which is B. So again, we deal with theta and h until we get a relationship, and then we substitute. That's why they tell you this is 30, so they make the triangle easy, 3, 4, 5, and you can easily find anything you want from it. Last but not least, number 45, and then we will move to section 2 in the next session. Find the derivative. So they give you y equals natural log of 2x cubed over e to the 2x, and they want y prime. This is a quotient rule. Some people can write e to the negative 2x and make it a product. In fact, any quotient you can make it a product. It's like it's not a new rule. It's derived from that. But nevertheless, that's not our topic here. So when I take the derivative of a quotient, I take the denominator square, which is e to the 4x, right? And then I take the denominator times the derivative of the numerator. The derivative of a natural log, notice that you always have to use the chain rule, always. So what do I see? I see a natural log. You ask yourself, what is the derivative of natural log of x? It's 1 over x. So natural log of anything is 1 over that thing. And you say, no, but after I do that, I step inside, I see 2x cubed. I take the derivative of x cubed, which is 3 times 2 is 6x squared. So 6x squared. That's it. Minus the numerator times the derivative of the denominator. E to anything is e to that thing. And then you have 2x, so you multiply by 2. Okay, notice you have e to the 2x, e to the 2x, e to the 2x squared. So I can come here. Now, what do we have? They give you, do you see? What do we have? So I can simplify the first term. Let's simplify the first term. I have x squared and x cubed and 6 and 2. It's 3 over x minus 2 natural log of 2x cubed over e to the 2x. So I can write it as either two terms. I see it, it's c. So this would be, if the first term would be 3 over x e to the 2x minus 2 natural log of 2x cubed over e to the 2x, if you separate them, right? And I think that's c, 3 over x e to the 2x minus 2 natural log of 2x cubed over e to the 2x, so that's c. That's pretty straightforward. So maybe that is a little tricky, number 44, but, and the left Riemann sum, which is a right Riemann sum, was a typo, but I think it's not that hard. It should be pretty straightforward. I've seen, unfortunately, many typos in this test. So I will try to get one that is officially from, the official site, and maybe we can do some problems, because it's a very long test. It took us so far like 4 or 5 sessions, and we still didn't reach section 2. Anyway, I hope you benefited from that. If you have any questions or comments, as usual, I'm open to hear that, and I will try to get back to you as soon as I can. And otherwise, I wish you all the best and hope to see you soon. Bye.